Welcome everybody. We got an interesting question. So foremost, let me draw the all-important circle. It is creating a rectangle. There is a rectangle there. Now let me name this as DE. Okay, so this is the center of the violet circle. Now the question is, we will have to, so this is the rough figure, right? I've tried my best, and ACDE is a rectangle. ACDE is a rectangle, and we've been given AC. AC is 10 units and AB is 12 units. We are expected to find this shaded region, this shaded region, and this shaded region. So all of these three regions have to be found. So you can pause the video and think about it, and when we return I'll give the solution. Okay, I hope you all have got the solution. So AC is given to be as 10 units, so let me write that down, and AB is 12 units. Now ABC are points on the bigger circle, right? ABC. Now we can use this Thales theorem or Thales theorem. According to this theorem, if A, B, C are distinct points on the circle, and if AB is the diameter of the circle, then angle ACB will be equal to 90 degrees. So this point is 90 degree. Okay, so we can use Pythagoras. So by Pythagoras theorem, we get AC squared plus BC squared is equal to, this is the hypotenuse side, AB squared. Okay, so AC squared 10 squared, BC squared I do not know, I'm yet to find out. AB squared is 12 squared. This is 144 negative 100 is equal to BC squared. So BC is equal to root of 44. Now square root of 44, let me check that out. I got square root of 44. How can I write? Okay, I can rewrite this as 2 times root of 11 units. So that's fine. So BC is equal to 2 times root of 11. So this is 2 times root of 11 units. Okay, fair enough. Now I want to get this region, this region, this region. So for this region, okay, so let me write this one, R1, R2 and R3. So to get R1 and R2, R1 plus R2, this is the required region. The required region, okay, the required region R1 plus R2 is equal to area of rectangle. From the area of the rectangle, I subtract area of the semicircle. So you got two semicircles. So this semicircle, I'm naming it as C2, this one is C1, right? This circle is also a semicircle, this one is C1. Let me name this as C1. Okay, now area of the rectangle minus area of C2. Now area of the rectangle, how are we going to find the area of the rectangle? Can you tell me? Okay, that is simple. Now watch here, there is a point of contact, there is a tangency over here, right? There is a tangency over here and there is a tangency over here. So that would mean if I were to take this point as some P, then according to the two tangent theorem, if I were to get a tangent or two tangents drawn from an external point, then the length of the tangent would be one and the same. So there is a tangent here and there is a tangent here. So let me state that dP and dC are tangents to C2 by two tangent theorem. If tangents are drawn from an external point, their length would be equal. Okay, this means dP is equal to dC. Now you see, there is the point of contact is exactly hitting the center. So if I were to divide, if I were to drop a perpendicular, let me drop a perpendicular. So the rectangle is divided into two squares, and clearly if I were to divide this length is 10 units, I'm dividing it into 2 units, 2 segments, so this is going to be 5 units, so this is going to be 5 units, this is going to be 5 units. Now you might be wondering, why do I apply the two tangent theorem? Because I want to know this width. So the width is got, so now I can get the area of the rectangle. So therefore area of the rectangle is equal to length into breadth. So that's nothing but length into breadth or length into width. You can write anything like that you want. Okay, so the length is, what's the length? This is the length, 10 units multiplied by 5 is equal to 50 square units. Now we need to get the area of the circle. That is nothing but pi r squared. So what's the radius of the circle? So the radius is 5 units. You see that this diameter is 10 units, radius is 5 units. So this is going to be pi, and it's a semicircle. That is the important thing. We have to take note that this is a semicircle. Since a semicircle, we have to divide by 2. So 5 times is equal to 25 pi over 2 square units. So from the required area is area of the rectangle, that is 50 square units minus this one, area of the semicircle. So you take away this, you get R1 and R2. You are left with R1 and R2. Okay, so this is 25 pi over 2. I'm not going to do anything because we need to add this region, because we have to find R1, R2 and R3. So how are we going to get this region? Now finally we need to obtain region 3. Now let me go back to the figure. Now consider this figure which we have drawn. We have to obtain this R3. We have already got these two regions, right? So we have to obtain R3. Now before we could obtain R3, we will have to adopt this technique. Now, what is that technique? The technique is we need to find the area of the sector, and for that we need to get the value of theta. Now this is the center for this semicircle C1, and clearly this is the center point, and this AB is 12 units. So this region is going to be 6, this region is going to be 6. So the radius is 6 units. Now what I wish to do is from the center I am hitting the point C. That is actually a radius, right? So this is a radius, this is a radius, and a triangle is formed. Now if I were to take this triangle as AOC, clearly AOC is an isosceles. Now from the head of the isosceles, if I were to drop a perpendicular, that would be dividing the isosceles triangle into two equal parts. That would mean this is a 90-degree hit. So having got that 90-degree hit, and this is also a center, this entire thing is 10 units. So this is going to be 5 units, and this is 6 units. Now I will have to get, let me take this one as some cube. Okay, so my desire is to obtain theta. So before I could obtain theta, what I wish to do is I would want to find this length, right? And why do I want to find this length? Because ultimately I would want to get the area of the triangle. That is important. Area of the triangle is critical. So let me start off by consider triangle OQC. I am considering triangle OQC. As I mentioned to you, this is a right triangle. So by Pythagoras we can apply Pythagoras theorem. What do we get by Pythagoras theorem? OQ squared plus QC squared is equal to OC squared. Now OC squared is 6 squared. Now OQ is required, OQ squared is required, and QC is 5. So it's 5 squared. So this is 36 negative 25, which is going to be 11 units. So I have OQ squared is equal to 11, therefore OQ is equal to root of 11 units. So this side is got root of 11. Now this is 90 degree, so this is also going to be 90 degree. Now let me actually draw AOQ. So if we were to draw AOQ, this will look like this. So this is OQA, and this is 5 units. This is going to be root of 11 units. Now this is my theta. So having got this theta, and OA, this side is going to be 6 units. Okay, so we need, if I were to take cos theta is equal to adjacent side by hypotenuse. So my adjacent side is 5 units, hypotenuse is 6 units. So cos theta is equal to 5 over 6, therefore theta is equal to cos inverse of 5 over 6. So let me get my calculator. So let me start with cos inverse of 5 over 6, 5 divided by 6, that is 33 degrees. So I'm going to take theta to be as 33 degrees. So theta is 33. So let me go back to the figure. This part is 33, this part is 33. So I have to get this angle. Okay, So if I were to take this angle as some alpha, so therefore alpha will be equal to, from 180 degree I need to subtract 33 plus 33. That's going to be 180 minus 66. So 180 minus 66, that's going to be 114 degrees. So if I were to find the sector area, so the idea is like this. We will get the area of the sector. From the area of the sector, I will take away the area of this entire triangle. So let me find out the area of the sector. Area of sector is equal to 114 degrees divided by 360 multiplied by pi r squared. The radius of this particular circle is 6 units. So 6 into 6 divides here 6 times, 0 there, and this 6 divides here 10 times. So you have 11.4 degree multiplied with pi. So this is the sector area, square units. Now area of the triangle, if I were to take the area of the triangle, say, let me write this down. Area of triangle OQC is equal to half into base times height. So my base is 5 units, height is root 11 units. 5 into root 11. This is one part, right? There are two parts, right? So this is a part and this is a part. So total area should be obtained. I'm only getting one part, so I need to multiply this by 2. So that would be the total area. So let me just take this. This is equal to 5 over 2 root of 11. Therefore, total area of triangle AOC, this entire triangle AOC is going to be 2 times of 5 over 2 times root 11. That is nothing but 5 times root 11 square units. Okay. Now I need to get this segment. Now let me take this region to be as say some R4. Okay. Therefore R4 is equal to sector area. From sector area I take away area of triangle. So sector area is 11.4 times pi minus 5 times root 11. That is area of the triangle. Now we need to evaluate this to get R4. Now this is equal to, let me just do that. So 11.4, 22 divided by 7, that's a value of pi, multiplied with 11.4, that is equal to this. So this is equal to 35.82 or 35.83 negative root of 11 multiplied with 5. That is going to give me 16. So this 16.58. So 35.83 minus 16.58. So this is equal to 19.25 square units, which is that R4. Okay, I've got R4. Now I need to get R3. So this is the big challenge. So how do I get R3? R3 is got by taking the entire circle area. From the circle area I need to subtract this R4 and area of ACB, right? Area of the triangle ACB. That would give me this R3. So do I have a space? Okay, let me use this one. Therefore R3 is equal to area of circle from the area of the circle, I take away this area minus R4, and then I take away the area of this area of the triangle, ACB, right? So we need to get the area of ACB, right? Area of ACB, triangle ACB is half into base times height. So half into my base. What is my base? My base is 2 times root 11. 2 times root 11 times my height is 10 units. This entire height. Okay, 10 units. 2 gets cancelled. So this is 10 into root 11. So area of the circle is, it's a semicircle. Area of the semicircle. That's important. Okay, semicircle. So we are dealing with semicircle. So area of the semicircle is nothing but 1 over 2 times pi r squared. My r is 6 units. So 6 into 6. From this, from the area of the circle, I take away R4, I take away this area of triangle. So it's going to be minus of R4. What did we get for R4? Let me show that value. 19.25. I hope you're able to watch this. 19.25. So place 19.25. This has to be added with area of the triangle. That's 10 into root 11. So now we need to do some calculations. Of course, 2 divides here, 3 times 3 into 6, 18 pi minus root of 11, square root of 11, okay, multiplied with 10, okay, so added with 19.25. So that is giving me a value of 52.42. I hope you're able to see this. Now what is 22 divided by 7 multiplied with 18? That gives me 56.57. Lovely. Minus 52.42. So I'm just going to take two places out of the decimal. So 56.57 minus 52.42. So this is equal to 4.15. So what is this? This is nothing but my R3. This is the region R3. So now we have got this region. This region is obtained from the rectangle. From the rectangle I take away area of this semicircle, and I got these two regions. So that is 15 negative 25 pi over 2, right? So if I were to calculate this, let me calculate this value, right? So 22 divided by 7 multiplied with 25, and I divide by 2. So this is 50 negative 39.29. So what is that? 50 negative 39.29. That is equal to 10.71. So R1, therefore the required region is what? R1 plus R2 plus R3. So this R1 plus R2 we have got 10.71 plus 4.15. So that is going to give me 6, 8 and 14.86 square units. So that is the required region. So this is a beautiful problem. So thank you everybody. I hope you liked this question. Please like, share and subscribe to our channel for greater geometry skills enhancement.